Okay guys, in this video we're going to talk about area of similar figures. And so what we've got here is, let's say we have a triangle. All right, now we know that, let's first talk about similar figures. Similar figures means the shape, the angles are congruent. Okay, we have two shapes. The angles are congruent and the side lengths are proportional. Okay, and we usually talk about a scale factor when we're talking about similar figures. So a shape that's twice as big, or 3 times as big, or 2.5 times as big, whatever, right? So we have, just going to keep it fairly conceptual, but let's say we have a triangle with base and height. Okay, then we know that the area of this triangle, the area of the small triangle, okay, the area of the small triangle is equal to 1/2 base times height. So we already know that. You know, we've covered that before. But how does the area change? How does the area change if we have a triangle that has lengths twice as big? So 2h and 2b. Okay. Now, do you think the area gets twice as big? Does the area get you know, half as big? The same? 3 times as big, 4 times as big? What is the difference of the areas of these two triangles? So in other words, the area of the big triangle equals 1/2. Well, the base here is going to be 2b, and the height is going to be 2h. So the area of the big triangle here equals, it looks like 2 times 2 is 4. 4 divided by 2 is 2, so 2bh. Okay. So what is the difference then? What is the difference then between here to here? Okay. How much bigger is this? Okay. So how much bigger this is really, well, it looks like from 1/2 bh to get to 2bh, it looks like this got 4 times bigger. So this is 4 times more area. Okay, so this is 4 times more area. Okay, we're going to try to make, at the end, I'm gonna go through a couple of shapes, and then we're going to try to see if there's a pattern here. But for now, we'll just leave it that there's 4 times as much area in this case. Okay, next I want to look at a quadrilateral. Okay, so I've got a quadrilateral. Okay, now we know that the area of a quadrilateral equals length times width. Okay, so we'll say that this is L and this is W. Okay, so what happens to the area of this if we blow this up? Okay, so we've blown this up, and let's say we have 3L. So the area of the small figure is L times W. The area of the big figure, I want to blow this up 3 times. So it's going to be similar with a scale factor of 3. So here, let me just write this down, the scale factor. So the scale factor here was 2. Okay, this time our scale factor is going to be 3. So here our scale factor, all right, our scale factor is 3. Okay, our scale factor here is 3. Okay, just writing some notes down. Now, what is the area of this big rectangle? Is going to be, length is going to be 3L this time, so 3L times 3W, which equals 9LW. Okay. In other words, the area of this bigger quadrilateral is 9 times bigger than this. So this is 4 times as much. Not 4. Should be 9, right? Should be 9 times as much area. So this time we had 9 times as much area. This time we had 4 times as much area. So I'm not sure if we're seeing a pattern here. Let's just keep going. Okay. This time I want to look at Pentagon. Okay, so polygon. Okay, so I've got a pentagon, and let's say we have I don't know, let's say this is 2, or sorry, let's say this is 3, and this apothem is 2. Okay, so we've got just a general polygon here. I'm sorry, I'm giving numbers here, but I could say this is, let's say this is A, and this is, I don't know, S. So let me use what I've been using. So let's say this is A and S. Okay. Then we know that the area of this small figure is going to be, well, it's going to be 1/2 AP, right? Well, the P is going to be 5S, so 1/2 times 5S, we'll call that P, so 5S equals P, okay, in this case. So our area is just going to be 1/2 AP, right? What if we want to take this shape, though, and make it a lot bigger? Okay, now let's say I blew this up to be not just A, but let's say I made it 4 times bigger. Okay, 4 times bigger. So our new area, our area of the big shape, is going to be 1/2. Now the A is going to be 4A. And the perimeter is going to be really 4 times as big as this perimeter was. So it's going to be 4P. Okay, because each segment is 4 times longer, so if you add up all the segments, it's going to be 4 times the perimeter, right? Okay, so 1/2 AP. So this is going to equal, the area of the big guy is going to equal, and that looks like 16. 16 divided by 2 is 8 AP. Okay, so what's the difference here? Again, from the area of the small to the area of the big, this appears to be 16 times more area. 16 times more area. Okay, notice again that the scale factor here, let me write down the scale factor. Scale factor was 4. Scale factor was 4. Okay, so do you see any pattern? Okay, at first, we had triangles. Scale factor was 2. And we got 4 times as much area. Okay. Next, we look at different, quadrilaterals. Scale factor was 3, and we had 9 times as much area. Then we looked at some polygons, and we said, okay, the scale factor was 4, and there's 16 times as much area. You should start to see a pattern developing here. Okay. In other words, the area of similar figures, if you have the scale factor, so if two, let me switch markers here. If 2 figures are similar, if 2 figures are similar, and their scale factor is A to B, then their areas scale factor is A squared to B squared. Okay? So in other words, this scale factor was 1 to 2. Okay, the linear scale factor was 1 to 2, so its area scale factor was 1 squared to 2 squared, so 1 to 4. Same thing up here. This scale factor was the linear scale factor was 1 to 3. Okay, so if the linear scale factor is 1 to 3, then the area scale factor is going to be 1 squared to 3 squared, or 1 to 9. Finally, down here we had a scale factor of 1 to 4. Okay, since our scale factor was 1 to 4, then the area scale factor is going to be 1 squared to 4 squared, or 1 to 16. Okay, in this example, in this video, we only use 1 to something, 1 to 2, 1 to 3, 1 to 4. Okay, but of course, if the scale factor was 2 to 3, if the scale factor is 2 to 3, then the area scale factor would be 4 to 9. Okay, so you have to, it's not always you just square whatever the scale factor is and then that's it. You have to really focus on what this says. If it's 2 to 3, then the scale factor of the areas would be 4 to 9. Okay, so hopefully this gave you a little bit of an idea about how similar figures share a relationship in their area. In our next video, we're going to look at a lot of examples, try to solidify this point. Thanks for watching.